At Tektronix, the pioneering spirit is part of our heritage. Like the great innovators of decades past, we strive to develop new ways to solve problems and improve productivity for those we serve. To create products and services that deliver unmatched value, Tektronix has earned a reputation for continual innovation while placing a strong emphasis on the commercially practical. In our business, that's no easy combination. There's a catch in high technology. It can and often does create its own obsolescence. As a supplier, Tektronix is committed more to a long-term working relationship than to a single short-lived idea. 35 years ago, Tektronix was 6 people and 1 product, the best oscilloscope in the world. And while that original product is little more than a museum piece, to this day there's still no close second to Tektronix in cathode ray oscilloscopes. As a company of over 22,000 people with $1 billion in sales, we're not only a leader in oscilloscopes, but in all kinds of test and measurement devices, in computer graphics, in television operational equipment, and more, for over 50,000 customers worldwide. Our growth is built on our customers' growth. Year after year, they count on us for new, practical answers to their particular needs, designed to manufacture to the highest standards of quality. We offer more than inventions. We offer solid investments. That's the difference between the occasional good idea that's right for the time and the long-term value from good hard work that never goes out of style. Thomas Edison noted, "I am only a professional inventor. My studies and experiments have been conducted entirely with the object of inventing that which will have commercial utility." Edison was able to jump from one patentable idea to another, from carbon filaments to concrete houses. We hold hundreds of patents ourselves, but they've come one from the other as evolutions of our expertise and as outgrowths of customer needs. Year after year, in an industry where leadership can change with the next technological breakthrough, Tektronix stays out in front. Our management strategy is to lead our fields by leading from our strengths. This best serves our philosophy of controlled growth. It serves our customers' best interest too, because the lion's share of our research and development dollars continues to nourish the technologies they depend on. Today, our cathode ray tube products are far removed from our original product breakthrough back in 1946. Still, they're part of the same family tree, grafted from those original technologies. By taking a good idea and making it better and better, we've not only anticipated customer needs for scores of new test and measurement applications, we've kept the equipment compatible, familiar, comfortable. And we're not a me too supplier. We'll stay out of a market rather than compromise our reputation for quality. For Tektronix, patentable ideas are interesting, but marketable innovations are what we highly prize. Albert Michelson had a genius for devising extremely precise instruments to measure the speed of light. From his first $10 rotating mirror to his last mountain-to-mountain apparatus, he pushed accuracy to the limits. The demand for product capability today is becoming more individual and more exact. Our customers don't want to pay for more performance than they need, or for more performance than they get. We know that means more products, more ingenuity, more time and effort. There's no guesswork to Tektronix quality. When we say a product will meet certain standards of performance, it will. Improving performance may mean starting farther and farther upstream at the component level. New integrated circuits for service instruments, surface acoustical wave filters for television products, components for ceramic CRTs. They're all recently of our own design and an advancement of the art. Because we're one of the first and are now one of the most knowledgeable users of microcomputers, we're skilled at building programmable products that are easy to use for the broadening markets of non-technical operators. Most importantly, Tektronix instruments do what we say they will do. Our product specifications are tight and accurate. If a product fails to perform to published specifications, we correct it or replace it promptly. That promise is one reason we send all our products through at least 2 complete prototype builds, one more than do most suppliers. If our customers expect more from us, it's because we expect more of ourselves. It's no accident that among those who know us, reliability has become a byword for Tektronix. We set reliability goals for a product first, then set about to achieve them in a cost-effective manner. Each component manufacturing group is accountable for rigorous reliability programs, supplemented by corporate audits. In integrated circuitry, for example, we've established a checklist of 34 evaluation factors that are among the most severe in the industry. Precision instruments needn't be delicate. We torture our equipment under worse conditions than it will probably ever encounter. We send components and products through altitude tests to 50,000 feet. We put them through salt fog, sulfides, ozone, ultraviolet light, electromagnetic fields, static, shaking, shocking, and accelerated life tests up to months at a time. When products fail in the field, we find out why, too. Our reliability labs work with data computed from every field service warranty report for the last 10 years. We use this feedback from the real world to build better products, the kind our customers depend on when it really counts. Alexander Graham Bell's father-in-law and business partner, Gardner Hubbard, wrote with pride, "There are nearly 100 telephones in operation, and they have not failed in a single instance." But Bell knew that no piece of equipment could be counted on to last forever. We know the same is true for our products. So, to give them the maximum long-term value, our customers can count on this. Tektronix will support all of its equipment with parts and service for years to come. We arrange our service centers around 2 customer priorities: to respond as soon as possible, to maintain the product's value for as long as possible. You've only to walk through the rows and rows of vacuum tubes and aging racks at our home office service center to sense our commitment to long-term product support. With the singular exception of CRTs, we haven't manufactured a vacuum tube-based product in years. We support every part of every product for many years after discontinuation. In addition to a large investment in inventory, we have a separate manufacturing operation that builds replacement parts for discontinued items. There are approximately 1,300 service people around the world exclusively dedicated to servicing Tektronix products. Our training programs, our service bulletins, diagnostic tools of our own design, they all contribute towards making our service people among the most technically adept in the world. We're prepared to train our customers' own service people or troubleshoot over the phone, and one policy is certain: no Tektronix product is introduced until service support is solidly in place. Because Marie Curie built her case for radium carefully on solid pieces of measurable evidence, the strength of her discovery could not be disputed. Her perseverance and confidence earned for her the Nobel Prize. Corporate strength can be measured too, by satisfied customers, sales, profits, personnel, assets, technology, earnings, and new products. To build up one far ahead of the other sends cracks through the foundations. We're building on a rock-solid foundation to meet customer needs for years to come. Lasting strength results from building in balance, not for 1 year, but consistently over the continuum. Like Madame Curie, we have a sense of purpose, goals, and the determination to achieve them. From the outset, we've placed a premium on thoughtful, far-sighted management. We own virtually all our own properties. Our diversification has been planned so that no one product line or no one customer accounts for a disproportionate percentage of sales. Internally, we've evolved an unusual system that encourages creative thinking and technical competence. Our people know that there is no limit to their advancement potential. A former electronics technician, for example, is now president of Tektronix. We know our customers' investment is in much more than electronic hardware. It is in the people, the service, the corporate strength behind them. Sir Ambrose Fleming's invention of a thermionic vacuum tube put the first reliable tool for measuring signal strength into the hands of technicians. We admire that kind of contribution. It's the kind our customers look for, too, in choosing a supplier. Fleming expressed another important aspect of making progress with these words: cooperation can bring about better results than working alone can ever achieve. We admire that kind of spirit. Our purpose is clear. We want to establish a long-term working relationship with each customer. Most likely, we'll both have much to gain. Tektronix offers its record of product innovations to help give our customers the competitive edge in their markets, a reputation for product quality and reliability to meet the demands of their field environments, extensive assistance with training and new applications, and responsive service through a worldwide network of offices. Despite our increasing size and complexity, Tektronix remains a very personal company, and every employee has a take-home stake in customer satisfaction. Over the last 7 years, about 20% of our paycheck has depended on profit sharing. Whether it's electronics, telecommunications, defense, education, or any other industry we've chosen to serve, we want to be a contributor towards increasing productivity, improving product or service performance, or solving difficult problems. Take a closer look at our company and look to us to pioneer practical innovations. We're Tektronix, a company of people committed to excellence.
This room full of high technology products is brought to you by the folks at Tech Wilsonville. Hard copy units, plotters, terminals, they all come out of these buildings. Come on, let me show you around this place. One of the things you don't see is the way these buildings are put together. The thermal resistance of these walls, these windows, and that roof up there are 2 to 3 times higher than in other tech buildings. Think about that for a minute. What it means is this building doesn't need a heating system. Well, that's an exaggeration. There is a system, but it's used only occasionally, like on those frigid days. The rest of the time, the heat produced by half of these lights is enough to keep it comfortable in here. The net result is that these buildings use considerably less energy per square foot than similar space at Beaverton, for example. But the real story of Wilsonville is what happens inside these buildings. What comes out, of course, is those remarkable tech instruments, the plotters, the terminals, the hard copy units, and the graphic computing systems. But getting them put together with a tech commitment to excellence means a steady stream of first-class assembly techniques and the support people who make that happen. It all starts with design and carries through to the manufacture of components and doesn't end until the finished product has passed rigorous testing. And in reality, it doesn't begin here. Tech Wilsonville is part of a manufacturing loop that includes what happens in other nearby locations. Vancouver. Here's where we get plastic parts and things like cables and other components. Plastic parts start out this way, as tiny pellets. And it takes intricate tools and dies, some of them weighing thousands of pounds, to make finished parts. Smaller injection molding machines turn out different kinds of parts, like this roller, which goes to Wilsonville to become an element in a hard copy unit. Tech Beaverton, too, is an integral part of the Wilsonville story. Here's where circuit boards begin to take shape, where holes are drilled automatically, and where they get a final okay from an inspector. Elsewhere in Beaverton, metal cabinets are being readied. The final touch here is the riveting gun. Making complex cathode ray tubes involves a series of exciting steps. Here's where the phosphor coating is put on. And here's where the air is pulled out and it becomes a vacuum tube. And then, after still more testing, it goes on to a truck, together with those other parts, for the short trip south to Wilsonville. And this is where they're unloaded and where they begin to take shape. It's complicated back there, where the actual assembly takes place. Different parts going into different areas to make different products. But here's something that's common to most of them, an etched circuit board. And if you follow me, I'll show you how they're put together. Here's the place, a sprawling and busy place. Let's look around. Here's where integrated circuits go onto the board. And there are only 2 of these machines at Tech, both of them here at Wilsonville. They're like magic to watch. And so are these magic fingers. As always, though, testing is the final step. Automated test machines make the process a lot easier these days. This one checks individual circuits. And this one looks electronically at the whole board and spells out its findings for all to see. Whoops, didn't make it. Well, that's what tests are for. Let's try again. Ah, success. And a completed board. A marvel of technology. If you haven't guessed it by now, Wilsonville is computer-oriented. Not only the finished products, This is a place that uses computers to make related graphics products. There are 2 computers here, both of them heavily used. Engineers are among their best customers for designing software and circuits, too. In fact, there's a whole world of design inside these buildings. Final assembly, where pieces come together and products come out. In this case, Tek's hard copy units. And elsewhere, other assembly experts take over. It's tricky work with a lot of skill involved. Designing, building, and of course, testing. It just wouldn't be a Tek product without extensive testing. Now watch this. Here's where some of the more dramatic testing takes place. Keep your eyes on that shake table. That's a 4016 inside that box. They just tested the packaging. Yep, it held up. And if you think that's something, wait till you see this. There's a lot more, too. Here's where you'll see it all, right inside this door. This is Kevin Van Homesen, who has shown a lot of people through this room. Kevin, what instruments are here?
Well, in this room, we have a full range of graphic display products, and that includes copiers, plotters, totally self-contained graphic computing systems, and a variety of peripherals. And I'd like to begin by showing you the 4014, which is one of the more popular products, and it creates a graphic picture on screen by putting up vectors. It looks like this. If we want to combine alphanumerics and graphics on the same screen at the same time, we can put up a picture which is essentially line segments, and then the identifying graphics that go with it. In addition to being able to put an image on the screen, we can also make a copy of whatever image appears on the storage tube, and it looks like this. The time for that first copy is about 8 seconds. This is a very useful feature for people who are doing programming and preview of design. You notice the high resolution of that copy. In addition to using the storage tube for graphic displays, we've also been using raster technology. And when we use that kind of technology, we're able to store programs and functions locally. For example, in the 4025, we can load a specific program under a specifically addressable function key. This particular stored program calls out the feature set of the 4025. Other particular function keys have been programmed to display this kind of information. As you can tell with raster technology, you have the ability to use what we call shades of gray. We can have fields on top of other fields, protected fields, blank fields, blinking fields, and underlined fields, and so on. And in keeping with our programmability of the entire keyboard, we can also copy the entire memory of the terminal. Where the storage tube actually has a phosphor that is in the memory medium, in the raster devices we have ROM and RAM memory. So what's occurring now as we cycle through these 3 copies is that the hard copy unit is reading the stored hardware memory of the terminal. You've noticed that all of our products in this particular case are what we call monochrome. What we'd like to do now is to step over to the 4027. Now we're in full color. The 4027 is one of the most exciting developments in graphics in several years. With our 4027, we can put up 8 colors on screen at any one time from a total palette or combination of 64 colors. To give you an idea of why that's useful to someone in various applications, let us take a look at a particular architectural design. Architects, interior designers, people working in process control, and people whose job it is to create high-impact management graphics have been all very much impressed with the 4027. It has some unique capabilities. One of the important aspects of computer graphics is the capturing of the digital information in the opening part of the process. There are a variety of ways of doing this particular activity. They're called pens, light pens, the device I have in my hand, which is called a digitizer. And what we'd like to show you now is just an example of how a graphic picture is created, how the data points are captured and subsequently replayed back on a plotter. On our tablet to our left, which is essentially a digitizing tablet, we have a sketch of a picture. If I move this sensing device across through the points, you'll see that the line is displayed on the terminal. If I come up, I continue to get an outline of the particular image that I'm drawing here, which happens to be the boat. You'll notice that my sketch is rather ragged, and with computer graphics we have various smoothing programs which will help us make sure that the picture is exactly what we want it to be. What we've essentially done with the graphic tablet is to capture digital information. Now, if you look at this particular device, it works something like an electronic Etch-a-Sketch. Now that I have the data points captured, I can move over to another device, which is called a digital plotter, which will read those points and play it back and give me an image on paper. And if you think this is impressive, wait until you see the 4054. The 4054 has the unique combination of dynamic graphics and stored graphics in a desktop mini computer system with graphic peripherals all rolled into one package. What you'll see in this particular frame is the combination of a stored piece of geography and dynamic airplanes flying over the terrain. The stored information is the terrain, the dynamics are the airplanes. Very impressive. It's the combination of microcomputer technology. What do you think?
I'm impressed, Kevin. Quite an operation here. A good portion of tech products and a big piece of tech profits. Wilsonville is big news, but it doesn't stand alone. In a sense, it stands side by side with those other people back in Beaverton and over in Vancouver and the whole tech family. And what is the commitment here? You probably recognize the words